Hey, what's up guys? Welcome back. In this section, I'll show you how to control the robot using the smartphone's accelerometer. But before we control the robot using the accelerometer, let us first understand the basics of accelerometer. An accelerometer sensor is a device that measures acceleration, that is, the rate of change of velocity of any object. All existing smartphones consist of an accelerometer sensor, and whenever we tilt the smartphone, there is a change in the X, Y and Z axis of the smartphone. That is measured by the smartphone's accelerometer. So, for example, if you hold your smartphone horizontally like this and start moving it, then whenever you turn your smartphone in this manner, then there is a change in the X-axis of the smartphone's accelerometer. If you flip your phone in this manner, then there is a change in the Y-axis. Similarly, if you turn your phone horizontally like this, then there is a change in the Z-axis. So guys, after explaining you the change in accelerometer's axis according to the movement of your smartphone, in the next video, we will create a very simple Android program for plotting the change in accelerometer's value. Hey, what's up guys? Welcome back. In this video, we will create an Android application called as accelerometer reading, and in this application, we will plot the change in the X, Y and Z axis of the smartphone's accelerometer. Now guys, even though we are plotting the change in the X, Y and Z axis of the smartphone's accelerometer, for controlling a robot, we will only make use of the X and Y axis. That is, for controlling a robot, we will only take X and Y value as the inputs and we will ignore the Z value. So guys, as you can see, I've already gone ahead and created a new application called as accelerometer reading. So I'll request you all to go in projects, start new project and create a new application called as accelerometer reading. Now inside this application, first I'll go in layouts and I'll drag 3 horizontal layouts. I'll place the 3 layouts one below the other. After that, I'll change the width of all the layouts to fill parent. I'll leave the height to automatic. Next, I'll go in user interface and I'll drag 2 labels inside these horizontal arrangements. So I'll drag 2 labels inside each arrangement. And since this layout is horizontal layout, you can see the labels are placed horizontally over here. Next, I'll change the component names of label 1 to X, label 3 to Y and label 5 to Z. So I'll click on label 1. I'll rename it to X. I'll rename it as capital X. I'll change the label 3 name to Y and I'll change the label 5 name to Z. After that, I'll change the component name of label 2 to X value. So I'll write this in small, X value. Label 4 will be renamed to Y value. And label 6 will be renamed to Z value. Okay. Similarly, I'll change the text of text for label 1 to X. So I'll rename this text to X. So I'll write X colon. I'll change the font size to 30 as the font size is very small. I'll change the text for label 3 to Y. I'll change the font size again to 30. And I'll change the text for label 5. Next, I'll change the text for label 2 to 0.0. I'll increase the font size to 30 again. Okay, sorry, this should be 0.0 and the font size should be 30. Next, I'll drag a button over here which is below this horizontal arrangement 3. I will rename this button as accelerometer button. I'll click OK and I'll change this label name to accelerometer value. I'll increase the font size a little bit. I'll change the font size to 25. Okay, I'll change the font size to 20 and I'll increase the width to fill parent. Okay. So guys, let me explain you how this application will work. Now, whenever you tilt your smartphone in any direction, So during that time, you won't notice any change in the X, Y and Z values. But after you click on this accelerometer value button, so during that time, you will notice the change in the X, Y and Z values. So this is how we'll plot the change in X, Y and Z values. And depending on the change in values, we will further use these values for controlling a robot. So guys, I basically designed the user interface of the accelerometer reading application. Now there is one more component that I have to add. So the accelerometer sensor is available in the sensors option. After that, I'll drag the accelerometer sensor on the screen. Now, as you can see, the accelerometer sensor is a non-visible component. Next, I'll go inside the block section. Now, inside the block section, I'll first select the accelerometer button and I'll choose the accelerometer button dot click block. Now, inside this block, I'll put a block from the X value. So guys, as you can see over here, I've selected the X value block and not the X block. Now from the X value block, I'll choose this dark green block. And from the properties, I'll choose a property which says text and I'll put this block over here. So since I want to change the text of the X value from 0.0, as you can see currently the text is 0.0. So as I want to change the text from 0.0 to whatever the new value of acceleration is, so for that, I'll click on the accelerometer sensor block, and from the accelerometer sensor block, I'll choose this block which says accelerometer sensor 1.xaccel. So now when the user clicks on the accelerometer button, so during that time, the text of X value will change from 0.0 to whatever the new value of acceleration is. After that, next I'll right click on this dark green block and I'll click on duplicate. After that, I'll put this block over here and instead of X value, I'll change this to Y value, and the X acceleration, I'll change this to Y acceleration. I will right click on this Y block and I'll click on duplicate again. I'll put this block below the Y block and I'll change this to Z value and I'll change this to Z acceleration. So guys, I basically finished with the accelerometer reading app. So guys, after completing the app, next I'll request you all to click on build and you can either scan the QR code or you can download the APK file inside your computer. In the next video, I'll show you how to plot the X, Y and Z values. Hey, what's up guys, welcome back. In this video, we will plot the X and Y values by tilting our smartphone forward, backward, left and right. Once we get these values, we will use these values as inputs and then move our robot in multiple directions. Now, before I start plotting the values, if I tilt the phone forward and backward like this, then there will be a change in X-axis. If I tilt my phone left and right like this, then there will be a change in the Y-axis. So next, I'll open the app. After opening the app, as you can see, if the phone is flat on the table, then there is no change in the values. If I tilt my phone in the forward direction, and now if I click on the button, then you can see I'm getting the X value to minus 3.91. So minus 3.91 is less than minus 3. So if I want to move the robot forward, then the X acceleration value should be less than 3. That is minus 4, minus 5. After that, if I tilt the phone backward, then the X value is 3.81. So if I want to move the robot backward, then the X acceleration value should be more than 3.81 or it should be more than 3. If I tilt my phone left, then you can see there is a change in the Y-axis and the value of Y right now is minus 3.40. So if I want to move the robot left, the Y acceleration value should be less than minus 3, that is minus 4, minus 5. If I tilt the phone on the right, then the value of Y is 3.5. So if you want your robot to take a right turn, then the Y acceleration value should be greater than 3, that is 4, 5, 6, etc. When your phone is flat, the value of X and Y will be 0. But guys, since the accelerometer sensor inside your phone is very sensitive, even a small jerk will be noticed and the value of X and Y will become more than 0. So for the stop condition, instead of using a single value, we will use a range between X and Y. That is X greater than 0 and X less than 1. And on the Y side, we will take Y greater than 0 and Y less than 1. So guys, when we take this condition, then even if you tilt your phone by a small angle, the robot will not move. So guys, after plotting these values, let us use these values in our next program where you will control the robot using the smartphone's accelerometer. Hey, what's up guys? Welcome back. As you can see, I have created a new Android app called as ACCELEROCONTROL robot. So guys, in this video, we will design the user interface for the accelerometer control robot. In the previous video, I showed you how to read the X and Y values from the smartphone's accelerometer. So in this ACCELEROCONTROL robot application, we will use these X and Y values as input and we will try to control a robot. Now guys, if you remember in the previous video, when I was plotting the change in the X and Y value, I had hold my phone in the landscape manner, and currently as you can see, this screen is currently in portrait orientation. So the first thing that I'll do before adding any component is I'll change the orientation from portrait to landscape. So I'll select the screen one component over here. Next, I'll go in screen orientation and I'll change the orientation from unspecified to landscape. So now as you can see, the screen is changed to landscape. Next, I'll add the list picker component. After that, I'll rename the list picker component name to accelerometer picker. I'll click OK. Next, I'll change the width to fill parent. After that, I'll change the text to connect. I'll change the font size to 20. And at the last, I'll change the background color to green. Okay. Now after adding the list picker, next I'll add a button. Now this button will be for disconnect. So I'll rename the component name to disconnect. Okay. After that, I'll change the font size again to 20. Next, I'll change the width to fill parent. After that, I'll change the text to disconnect. Okay. And as we have done previously, I'll change the background color to red. And I'll change the text color to white. Now, after adding the list picker and the disconnect button, next I'll go in layout, and from the layout you can drag either the horizontal arrangement or the vertical arrangement. So I'll drag a horizontal arrangement over here. After that, I'll change the height of this arrangement to fill parent, and I'll change the width of this arrangement also to fill parent. So guys, you can see over here, since I've changed the height and width to fill parent, the horizontal arrangement is occupying the entire width of the screen, and the maximum height of the screen, the remaining height, is occupied by the connect list picker and the disconnect button. Now inside this horizontal arrangement, I'll drag a label. So let me tell you why I'm using this label. Now guys, whenever you tilt your phone in the forward, backward, left and right direction, so during that time, this label will keep on changing depending on the values. So for example, if you tilt your phone in the forward direction and if the value of X is less than -3 and if that condition corresponds to forward, then the text of the label will change to forward. If you tilt your phone in the left direction, then the text of the label will change to left. Similarly, if you tilt your phone on the right, the text will change to right. Next, I want this label to be in the center of the screen. Now, since this label is inside the horizontal arrangement 1, so I'll click on horizontal arrangement 1 and I'll change the alignments of this arrangement. So I'll change the align horizontal to center and I'll change the align vertical also to center. So currently the label is in center. Next, I'll change the text of this label to stop. So by default, this label will show the text stop, and next I'll change the font size of this to 40. Okay, 40 looks a little small, so I'll change this to 45. So guys, this is how the user interface of the ACCELEROCONTROL robot application will look like. Next, we need to add two components, and those components are the accelerometer sensor. So I'll go in the sensors option and I'll drag the accelerometer sensor option. Next, I'll go in connectivity and I'll drag the Bluetooth client 1 option. So guys, I basically finished with the user interface of the ACCELEROCONTROL robot, and I've also added the necessary component inside this app. Now in the next video, we will finish the graphical programming for this Android app. Hey, what's up guys? Welcome back. In the previous video, we finished designing the user interface for the extra control robot. Now in this video we will go inside the block section and we will finish the graphical programming for our extra control robot. So I'll go in block section, and inside the block section I will first use the blocks to enable the smartphone's accelerometer. So to enable the accelerometer sensor from the smartphone, I'll click on screen 1. Next, I'll choose this block which says when screen 1 dot initialized, and inside this block I'll go in accelerometer sensor now, and I'll put this block which says accelerometer sensor 1 dot enabled, and I will set the enable block to true. So I'll go in the logics block, and inside the logics block you can see I have the true block. So basically the accelerometer sensor will get enabled as soon as the screen is initialized, that is as soon as the application starts. Next, I will use the before picking and the after picking block. After this, I'll enable the after picking block. I'll choose a property of selection. And I'll connect it with the selected Bluetooth device from the list. Next, I'll collapse all the 3 blocks. I'll just rearrange them on the top. Next, we will do the graphical programming for the disconnect button. So I'll select the disconnect button, and when disconnect button dot click, I'll disconnect both the Bluetooths. I'll collapse this as well. Now after completing these 4 blocks, next I will go in accelerometer sensor 1 and I will choose the accelerometer sensor 1 dot acceleration change block to detect the change in the X and Y values. Now before we start comparing the X and Y values inside the acceleration change block, I first need to check if the Bluetooth and the accelerometer sensors are enabled or not. So to check that, I'll go in control first, then I'll select this if loop. Now inside the if loop, I'll add an AND block. So to add the AND block, I'll go in the logics block, and inside the logics block you can see I have the AND block. Now inside the AND block, I'll put 2 blocks. One will be the Bluetooth client 1 dot enabled. So the Bluetooth client 1 dot enabled block is inside the Bluetooth 1 block. So I'll put it in the first socket. The next block will be to check whether the accelerometer sensor is enabled or not. And we have already enabled the accelerometer sensor when screen is initialized. So guys, if the Bluetooth sensor and the accelerometer sensor, so if both the sensors are enabled, then this if loop will be true and the program will enter inside the if loop. That is, we can start adding blocks inside the then socket and these blocks will keep on executing. Now after enabling both the blocks, next we will use 5 if loops for comparing the X and Y values, and these 5 if loops will be for forward, backward, left, right and stop. So I'll go in the control blocks again, and next I'll choose this if loop, and inside this if socket I'll use a comparison block. So the comparison blocks are in the math block, so I'll go in math block and I'll choose this block which has an equal to symbol. Now the first if loop is to check for the forward condition. So guys, if you remember, when I tilted my smartphone in the forward direction, so during that time there was a change in the X axis and the value was in minus. So I'll select the less than or equal to sign and I'll put this block over here. After that I'll go in accelerometer sensor 1, and next I'll choose the accelerometer sensor dot X axle, and inside the next socket I'll put a math block. So I'll go in math block and I'll choose this integer block. I'll put it here and I'll set it to less than -3, because when we tilted a smartphone in the forward direction, so during that time we were getting the acceleration value of -3 point something something, which is actually less than -3. So if the X acceleration value is less than -3, that is -4, -5, -6, then we will send an integer data from the Bluetooth. So I'll go in the Bluetooth client 1 and I'll use this send 1 byte number, and the integer that we will send for forward will be 1. Okay, and when the Arduino receives this integer 1, it will move the robot in the forward direction. after sending the number 1, next I'll go in label 1, and inside the label 1 I'll choose the block which says set label 1 to text, and inside this empty socket I'll go in the text block and I'll put an empty string, and this empty string will correspond to forward. Okay, so not only will the Bluetooth send a number 1, but in place of this label which says stop, okay, the text of the label will change to forward as well, so that you can figure out whether the acceleration value is gone below -3 or not. Next, I'll click on duplicate and I'll duplicate this block. I'll put it below this if loop, and this time we will change the x acceleration value to greater than 3. And if you guys remember, when I moved my phone in the backward direction, so during that time the x acceleration value was more than 3, that is 3, 4, 5. So when the x acceleration value is more than 3, I'll send a number 2 and I'll change the text to backward. After this, I'll again duplicate this block. I'll put it below over here. Now next I'll compare the y acceleration value. So first I'll do if y acceleration less than -3. So if the y acceleration value is less than -3, the label will print left and we will send an integer 3. I'll again duplicate this code, and after comparing for the left, I'll now compare for the right. So if y acceleration is greater than 3, then I'll send a number 4. And last, I will add a condition to stop the robot. Now guys, for stopping the robot, instead of using a single value of x and y acceleration, I will use 4 values. Okay, 2 values of x acceleration and 2 values of y acceleration. So basically, I'll set a limit between 0 to 1, and if the phone's x acceleration and y acceleration is between that limit, then the robot will basically stop. So inside the if loop, I'll first add 3 AND blocks. So I'll add this AND block over here. So currently with 3 AND blocks, I can put 4 conditions over here. After this, I will click on the blue block, which is the outermost block, and I'll click on duplicate. Okay, and I'll duplicate this block 2 more times. Now after duplicating the block, first I'll change the top block from y acceleration to x acceleration. So if the x acceleration value is greater than or more than 0, next I'll change the y acceleration again to x, and if the value is less than 1. So as I told you, I'm using a limit between 0 and 1. Similarly, I'll change the y acceleration and set it to greater than 0 and less than 1. Okay, next I'll put these blocks inside these blocks. After putting the x block, I'll put the y blocks. So guys, if I read out the final if block, then this block basically compares the limits of x and y acceleration. So if the x acceleration value is more than 0 and if the x acceleration value is less than 1. So if your smartphone's x acceleration is in the limits of 0 to 1 and if your y acceleration is also in the limits of 0 and 1, I will print the condition of stop, and for stopping the robot, I'll send a number 5. So guys, I basically finished programming the accelerocontrol robot. If I run through the code once, so first we are basically enabling the accelerometer sensor. Next, we are using the after picker and the before picking block to enable Bluetooth connection between both the Bluetooths. Next, we are using the disconnect block. And after that, next in the main acceleration change block, we are first enabling the accelerometer sensor and the Bluetooth sensor. That is, we are checking if the Bluetooth client and the accelerometer sensor 1 blocks are enabled or not. If they are enabled, then first, if the value of acceleration is less than -3, then the label will print forward and we will send a number 1 to the HC05 Bluetooth. if the x acceleration is more than 3, that is, if you tilt the phone backward, we will change the text to backward and we will send a number 2. Similarly, if you tilt your phone in the left direction and if the y value is less than -3, that is -4, -5, then the label will change to left and we will send a number 3. If you tilt the phone in the right direction and if the y acceleration is more than 3, then okay, over here I forgot to change the left to right, so I'll change this to right over here. Okay, so if the y value is greater than 3, that is 4, 5, 6, then we'll print a text of right and we'll send a number 4. And at the last, if the x acceleration and the y acceleration values are between 0 and 1, then we will print a label stop and the Bluetooth client will send a number 5 to the HC05. So guys, that's it from this video. In the next video, we will finish the Arduino program for the ACCELEROCONTROL robot app. Hey, what's up guys? Welcome back. In the previous video, we finished the graphical programming for the ACCELEROCONTROL robot. Now, in this video, we will write the Arduino program for my ACCELEROCONTROL robot. But before I start writing any program, let me give you a small good news. And that good news is you do not need to write any Arduino code for the ACCELEROCONTROL robot because you can directly upload the SmartBot Arduino code inside your Arduino, and using this code itself, you can control your robots whenever the smartphone is tilted. So guys, as I told you, I won't be writing any code for the ACCELEROCONTROL robot Android app, and I'll just save this program by giving this a new file name. Okay, but before I save this program by a new file name, let us compare the if loop values of the SmartBot Arduino program with the ACCELEROCONTROL robot Android app. So first, as you can see, if you tilt your phone in the forward direction and if the value is less than -3, that is -4, -5, -6, so during that time we are sending a number 1 from the Bluetooth client, and if the number 1 is received by the Arduino code, then we are moving the robot in the forward direction, that is high low high low. After that, when you tilt the phone backward and if the number is greater than 3, then the Bluetooth client will send a number 2, and inside Arduino, if you receive the number 2, we are moving the robot backward, that is, we have set a condition of low high low high. Similarly, if I tilt my phone in the left direction and if the value of y is less than 3, that is -4, -5, then I'm sending a number 3 from the Bluetooth, and if this number is received by the Arduino, then my robot will take a radial left turn. After that, if I tilt my phone in the right direction and if the y value is greater than 3, then I'm sending a number 4 from the Bluetooth, and when the number 4 is received, the robot will move in the right direction. That is, it will take a radial right turn. And at the last, if the value, okay, and as I was saying, if the x acceleration and the y acceleration values are between 0 and 1, then I'll send a number 5. And when the Arduino, and inside the Arduino, when we receive the number 5, I'll basically stop the robot. So after comparing the Android and the Arduino code, next I'll click on File, I'll click on Save As, and I'll save this program by the name of ACCELEROCONTROL robot. I'll hit Save, and there is no need to compile this code as I've just renamed this code from SmartBot to ACCELEROCONTROL robot application. So I'll directly upload this code. And after uploading the program, next let's check the output.